Recording. Okay. So the course content for today is polymorphism and method overriding. Okay. Now, if I go below and see what are the contents, like method overriding, we have already discussed in the last class itself. So mostly we'll discuss on the various aspects of polymorphism. So polymorphism we have discussed number of times before, right? Like say during the demo classes as well, and during the basics of object-oriented concepts, we discussed about polymorphism. Now, what is polymorphism? So polymorphism is like uh, the ability to take many shapes is what is understood by polymorphism. Guys, please go on mute. Okay, thank you. So the ability to take many forms is what is known as polymorphism, and in Java world it means that the method name is same, but the behavior is different. Okay, and while discussing about inheritance, we discussed about method overriding, and while discussing about like say polymorphism and such before, we talked about method overloading. Okay, so let's take an example again. Now, I mean, see this particular example. Now there is a class overloaded, right? And this overloaded class is referring to a demo class. Now this demo class as such is out here. Okay, so there are three methods there: add, and add. But in the first one it accepts two integer parameters. In the second one it accepts three, and in the third one it accepts two. One is double value and one is integer value. Now, once you have this, depending on your requirements, you can either pass two integers, you can pass three integers, you can pass one double value, one int value. So if you see here, there are three calls: object.add25, object.add. Okay, fine, I'll reduce the size. Object.add25, object.add259, 3.14159110. So depending on the parameter type like int, compiler either invokes this particular method, JVM as such invokes this particular method, or it invokes this one, or it invokes this one. Now, since here at compile time as well, when you're writing the program, you know that when you're calling .add 2, 5, this is a method which is going to call. So this is called as compile time polymorphism or method overloading. Okay, so there are two types of polymorphism. One is runtime polymorphism and one is compile time polymorphism. So what compile time polymorphism means is that at compile time, when you're compiling the program, at that time itself you know like how to which particular method has to be executed. Okay, so that is compile time polymorphism. Okay, now what about runtime polymorphism? So the runtime polymorphism is something which we are not able to understand or which we do not know when we are writing the program in the first place, and that is method overriding, right? It is method overriding because when at compile time you do not know which class will be used. Okay, and at runtime JVM does not know which method has to at compile time JVM doesn't know which method has to be executed. So there is a small mistake here. It's not runtime, it's compile time. Now coming to runtime polymorphism, right? So there are 5 different types, and let's not get bogged down by what are the things which are written here. We'll take everything one by one. One is polymorphic assignment statements. Now it is again of two types: primitive assignment statements and reference assignment statements. Now first consider primitive assignment statements. Now when you have a case like this, int z is equal to 10, double another variable double val is equal to z. Now the result in z is being assigned to double val variable. So here if you see it's an integer value and you're trying to convert it into a double value. So this is called as type broadening in Java world. So type broadening is possible. Okay, so if you're assigning like this and try to print double val, the value which will come out is 10.0. Okay, so but so there are two things. One is type broadening, which is out here. The other thing is type narrowing, which is out here. So if you see here, the value is double. Okay, double x is equal to 12.12. Now you're trying to assign int y is equal to x. So what that means is that this particular value 12.12 has been reduced to 12, because I mean when you're doing an arrow and this is a double value and you're trying to convert it into integer. Now if you remember, int only accepts numeric values, it doesn't accept decimal values. So whatever is there in the fraction like 12.12, 3.14, that 0.14 part or 0.12 part will go away. So if you print this one, what will remain is only the integer part, this particular part. So if you try to print y, that will come as 12. But again, I mean there is a caveat. And what is the caveat? The caveat is, since I mean we are doing a type narrowing, because from x to y, compiler doesn't know whether you want to do it or not. So it gives you an error message first saying that double value cannot be converted into an integer value. So for type narrowing, you specifically have to do a cast like this, that yes, this is a double value, but I want it to be converted into an integer. And compiler just gives you an error message because there is a loss of precision here. Okay, and when I say loss of precision, that loss of precision is because when you convert it into an integer, now integer doesn't accept the fractional values, double has fractional values. So when you're assigning it like this, the value of y will not be 12.12, it will be only the whole value, which is 12. So there is a loss of precision, you're losing 0.12. So you have to accept that this is fine, and that is via this cast, saying that whatever is a double value, convert it into an integer. Okay, so if we run it and see, and my suggestion to you would be, like when I send you these PPTs and otherwise as well, like these small programs, I mean go and try to run them as well. Okay, so this will help you in writing and being more familiar with the examples. So y is equal to 12. So this is the example which comes up. Now, so this is another type of polymorphic assignment, that you are using an integer to refer to a double, okay, or you are using a double to refer to an integer. So this polymorphic assignment is important, and this was with respect to primitives, but the other example is with reference to the reference data type. Okay, now let's take for an example inheritance. Okay, now when I say inheritance, and I am pretty much sure that you can see in this class, let's say we have two classes, right? We have first class, we have second class. So now let's go back here and try to create them. To go do a new class, then write it first class, and then you create it. So you can have other attributes inside this class. I just not put it so that I can only explain the concept. Now let's come here and put it as second class. So when you put second class and you have to extend the first class, right? Because that's what our thing is. So extend it. Now the second class extends the first class. So we have created these two classes, and let's write a test class from where we will check all this thing. So going here, doing a test first class. Okay, so if this is out here, we'll write the main method. In that main method, if we use say first class example1 is equal to new first class. Okay, so if we have it in this way, okay, now if you have a second variable, say second class, let's take a yeah, fine. So let's say the second class ext2 is equal to new second class. Now if you have it like this, right, and you come here and do ex2 is equal to ex1. Now if that is the case, this is a form of polymorphic assignment. But what is the case? See here, ex2 is referring to ex1 and you're getting the error. What is the error? Cannot convert from first class to second class. Why is that so? That is so because this is ex1 is first class, right? So if you see the reference variables, what they can do is they can refer to, see, reference data types can refer to objects of the same type. So whatever is the assignment on the right hand side, this has to be either a second class type object or of the derived classes, but not of the super classes. So that means is that if there is some other class, like say third class, and that extends the second class, so that in turn means that the third class derives, third class is a derived class or the second class, then you can refer to it, okay, but not like this. So what that essentially means is that when you are faced with situations like this, okay, what you need to check is whether the value on the right, okay, is whether the value on the right is of type same as reference data type, okay, or satisfies inheritance, which is a relationship. So you have to ask that question at the start. See, if you keep on doing this, I mean, it will become very easy for you over time, okay, but for now you just have to understand that either it has to be same object, okay, so either it has to be like, say, I mean, you can define another variable here, say second class ex3, and this is just a reference type, so it can exist like this. You can define like this and say ex3 is equal to ex2, and here there won't be any error, okay. Why? Because it's of the same type, right? Now so let's say example first class. So if you have first class ex1, not ex1, say ex4. If you have this and you use ex4 is equal to ex1, there are any problems? Obviously no, they are the same type. What if I refer to ex2? Will it have any problems? I don't think so. Why? Because when you ask is ex2 same as what you have in ex4, like first class, so the first question which you ask is ex2 same as first class? The answer is no. Is ex2 satisfies is a first class relationship? The answer is yes. Why? Because second class, if when you come here and say second class, I mean here, so like this. So second class when you define second class as when you define second class as extending the first class, so that basically means that second class is a type of first class. So that is a relationship is satisfied, okay, and when that is a relationship is satisfied, you can use the reference data type of the superclass, which is like say first class here, and use it to refer to that of the subclasses as well, okay. So and this is just a concept, so try to understand this particular line. Whatever I've written here is very, very important, that when just try to assimilate it, understand it as much as possible, that a reference data type can refer to objects either of the same type, okay, or of the derived classes. So it has to satisfy it is a relationship, okay. So whatever is there on the left hand side of the assignment, okay, the value on the right hand side either has to be the same value, same type as that on the right hand, as that on the left hand side, or if not, then it has to satisfy is the relationship, okay. So this has to be like very much true, okay. So this is because of type compatibility in Java, because you can't have a different type on right hand side and different type on left hand side, okay. So I mean, if you try to look into this logically, you'll get an answer, and you'll get an answer without even knowing whether this concept is there or not, or like whatever I have highlighted here. And think about it, like say if we have a second class, right? Now second class extends first class. So what that means? That means is, like say, let me add a method here. Okay, so I'll add a method public string uh, return data. And just for an example, let me leave, I will not pass any input parameter, I'll just return a value true. Okay, so this is one particular method which I've written first class. So essentially second class also has this value, but I can override this method. Okay, and instead of returning true from second class, I can return false. Okay, and apart from returning false, I can have an extra attribute as well in this particular class, which is say private string is privileged status. Okay, now if you see here, the first class, the super class did not have any attributes, but I added another attribute, one attribute in second class thing here. Now since I've added it here, maybe there's another method to use it. So let's call this method return privilege status. Now what this does is this just returns a value of privilege status. Okay, and since you have an attribute and this is private, so it won't be accessible from outside, right? So we'll add a mutator and accessor method, which is getters and setters. So we'll come here, generate getters and setters, and click here and then generate it. So once you have this, and you come here, see again. So what you now do is, I mean, as part of return privilege status is, I mean, you just return this particular value, which is privilege status. Okay, now let's come back here to this test class. Now say for this assignment, if Java would have made this as true, okay, if this assignment was true, what this would have meant is that first class object, we could have used a second class variable to refer to it. So ex2 would have referred to ex1 object. Okay, now if you try to understand the implications of it, now this means is that when you try to invoke a method from here, you can return this method as well, and this is perfectly valid. I mean, Java cannot say that this is wrong. Why? Because the reference data type is a type second class, and the second class you have defined a method get privilege status, return privilege status. So it has to be returned. But do you see the fallacy here? This ex1 is an object, is an actual object of first class. So if you assign it like this, first class doesn't have any return privilege status, so it would be wrong. So you are losing data out here. So that's the reason Java says that, boss, this is wrong. You have to modify it. Why the other way it is true? Like say if I use ex4, which is first class. Okay, now let's comment it out. If we use ex4, which is the first class, to refer to second class object. Okay, now why this is true? This is true because now ex4 can only refer to the attributes and the methods which are defined in this class, which by default is also accessible from the second class object, because second class object inherits, because of this particular scenario, because this particular extension keyword, extends keyword, it inherits all the attributes which is there in the first class, all the attributes and all the methods it has access to. So that's why this particular line which is out here is true, because it will not let you violate any of the other things which you write in the program. Okay, so if you think in this way, you will be able to understand whatever is written in this particular statement, and you won't have to like actually think about this particular statement and learn it and then try to apply it everywhere. Just think about it logically. Slowly and slowly this will become a second part of you. You'll be able to understand this in a much better way. Okay, now this is what I explained here, like what I said there. Now there is one way. Now what is that way? So that way is, if I go here and say from here I put a calf saying that no, I'll tell compiler that this is a second class object only. And why I'm telling this, because the value which I've used on left hand side is a second class reference data type. Okay, so I'll put it out here and do like this. So this gets satisfied, the error goes away, right? And so we are happy, so we can use it, right? That is not true. Let's try to run it. So if you run it, you'll see that there is one exception which comes. Okay. So why that exception comes? Because you cannot cast it like this. This is, I mean, an employee of first class cannot be cast to employees of the second class. Okay. Why? Because see, here you're trying to again cast it to second class. Now that essentially means the same thing. I mean, second class, the first class object you're trying to convert into second class. Now second class has additional features, right? Second class has additional features. So these values, whatever is out there, this is not there in the first class object. And if we do it like this, I mean, Java doesn't know what to put for it. So when you did a conversion and for primitive data types, let's try to relate it. So in the primitive conversions, what we learned before was there is type broadening. So what that means is, like, say int y is equal to 10, right? And then you have double. So double x is equal to, say, y. So this is a case of type broadening. You're converting an integer into a double. Okay, this is fine here. Why? This is fine here because you know that this is a fixed value and how it has to be treated in double. Okay, there is no loss of precision. But here, similarly, if you see type broadening in case of reference data type. So you had a first class object and you're trying to make it a second class. This is not possible. Why? Because here there's some additional attributes as well which has to be defined, which is not defined in the first class object. Now say for double, if double internally would have some additional attributes as well, which while defining a double value, and just for an example, like say hypothetical example, if double x1 is equal to, you have to define like say 10, and then you have to say double dot attribute, some random value. So double dot attribute has to be assigned every time for precision, and that has to be assigned like this. If you do it like this, and this is not a correct statement, just a hypothetical example, then there is some precision involved, right? There is some extra value which has to be involved. In that case, Java wouldn't have allowed type broadening. Okay, but since that is not the case, it allows type broadening in case of primitives, but type broadening in case of reference data types is not allowed. Okay, so this is what you have to keep in mind, and this is what I explained here. Now, so now if you come here and say why then Java allows this cast, it shouldn't have even allowed it, right? It should have still showed me that error. Why after casting it, the error which was coming before, the compile time error, it went away? I mean, this thing was giving me error, right? Then why Java is allowing me to convert to second class object from here and removing my compile time error and let it propagate to a runtime error? Why Java is doing that? Okay, so here is an answer for this. Now let's say we have learned, right, that a reference data type can refer to the objects of the same type or to that of the derived classes. So what that essentially means is, say for an example, ex1. So ex1 can refer to an object of type ex2, right? Because it is ex2 is a derived class for ex1. Now this is very much possible. ex1 can refer to ex2. Now since ex1 can refer to ex2, okay, if you do it like this here, or like say, I mean, if you run it, I think this should not give any error. Let's see. See, it did not give any error. Why? Because right now the value which goes here is referring to a second class object. Okay, so what is the type of the reference data type? I mean, which you're casting here doesn't matter, but to the actual objects. Okay, so you should always think from the actual objects perspective when you are on the right hand side of the assignment. When you're on the left hand side, the reference data type matters. Okay, and this is also possible. Say first class, you can use a first class object to refer to a second class object. This is pretty much possible. Okay, and if this is possible, you can assign it as ex5. Okay, why? Because this may be of type first class, but this is actually referring to a second class object. So this is pretty much possible, because if you do ex2.get is privilege call, which is only there in second class object, it will return you value because you're actually referring to a second class object. So these are the things which you have to uh, remember. And one of it is called as upcasting, and one of it is called as downcasting. uh, Upcasting or downcasting, one of them is allowed, one of them is not allowed. We discussed both of them here. Okay, so this is one of my assignment questions. I want you to go back and read about upcasting, downcasting, come back and say which one is allowed, and which one is not allowed. Okay, now let's leave it out right here and go ahead. So again, I mean, if you see here again the polymorphic assignment and the examples which I have put here. So what is the example here? The example is like whatever I explained here, this polymorphic assignment, right? Now, if you remember the polymorphism which we discussed before about method overriding and method overloading, it doesn't exactly satisfy that paradigm, right? And then why have we discussed it here? This is we have discussed because it is very important with respect to method overriding concept. And why? Because the thing is that even if you have it, I mean, unless you understand how it goes, the method overriding comes into picture, is helpful only because of this polymorphic assignment which we learned in first class and second class example. So let's take an example. If we have an abstract class, okay, if we have an abstract class like say called animal, okay, now how to create an abstract class? So the abstract class can be created in multiple ways. One is I can go here, use Eclipse thing and do a new class. There is an attributed abstract class and say I write animal. Okay. So if you see here, this particular class is created, and I define an abstract method also here. Public abstract like say the return value has to be string sound. So any class which implements animal has to implement this sound. Otherwise, it will remain as an abstract class. So if we have say dog, okay. So then another class is dog. Now dog implements animal. So I can choose the animal class, select it out here, and click on finish. So if we do that, this particular keyword comes here. So say if you forget, and we'll do it in the next class which we'll create, you can add this later and the same thing will satisfy. So here the sound of dog returns is bar. So I'll replace this particular value. Now let's create another class, say cat. So if you create cat, and here we'll purposefully not select the correct superclass and just let it propagate. So we have created one class cat. Now we remember that cat actually has to extend or inherit everything which is there in the animal class. So what do? You add the extends keyword by yourself and write the animal class by yourself. Once you do it, it says that you have not implemented the abstract method because that is required. So you do one click, okay, and you add unimplemented methods. You click on it, and then the sound method comes up. Now here you come and write whatever you want to. Okay. Now let's take an example. So we come here and say we'll run it. So we come here and say test. Okay. Now test animal. So that basically means is you want to get the sound, like what is the actual value. Okay. So once you come here, and as you remember, like say this is your interface, the main program's interface with the outer world. So what you pass in the argument, that is what you can expect and retrieve in the program here. So here, like say we have string and say animal type, okay, and we cast it to, I mean this cast is not required. Since this is an array, just choose one value, okay. So this is the animal type which you have. Now the animal type which you have, depending on that, you decide what needs to be done, right? Whether you need to call the cat class or whether you need to call the dog class. So let's come back to test animal thing. So if we have it here, one cases, like say the values which I'm expecting in one case is cat, okay. In the other case, the value which I'm expecting is dog, and then you have default. So see, to refer to all these objects, whatever is on the left hand side, we can always choose the superclass or the abstract class. So superclass here is abstract class, right? So this is my definition. Okay. Now here, if the value which you pass is cat, I want to assign it to this particular object. So the animal reference data type will refer to cat object. Okay. If we pass it as dog, we'll refer to it as dog. Okay. Now this is out. What is the definition? Now say if I want to print sys out and do animal dot sound. Now say what value will it print? Whether it will print bark, which we have in dog, or whether it will print meow, which is there in cat. Okay. So now here we do not know what needs to be done, and the reason behind that is what? The reason behind that is that, I mean, this is the case of method overriding. So you have an abstract class, or even if abstract class is not there, even if you have a normal class and you have some representation of or some implementation of sound here, you can go back to the subclasses or to the derived classes and can override the implementation of that method, or you can keep it, but you can override it as well. Now when you're running it, and this is called as method overriding, and when you're running it at runtime, we know whether the sound from this class has to be executed, or from the parent class, or from the other subclasses. So in this case, if you see, if I run it, I do not know what has to be done. Why? Because this animal will refer to either cat or dog, and it doesn't by default has a default implementation. So this is going to give an exception, because if I do not pass anything, I mean, this will give you a null pointer exception, because this particular case is not going to get satisfied, this particular case is not going to get satisfied, and the default value I have not done anything. Okay, so if, let's run it and see. So we have an exception here. Okay, and this the exception has come much before. The exception has come here itself. Why? Because we have not passed any input parameter. So how to pass an input parameter? Do run configurations, go here. So I did a right click, then run configurations, then arguments. Here you give, like say instead of cat, dog, you give tiger. So if you do that, there is an argument, but it doesn't satisfy these two cases. It satisfies a default thing, and in default you haven't done any stuff. Okay. Now to avoid that, what you need to do is you need to add a null check. If null is not equal to animal, okay, then you go ahead and print it. So what that means is that whenever the animal is not assigned any value, it is not going to do anything. Only when it is not null, you print this. Let's run it again. No results, right? Okay. So let's come here. And instead of tiger, let's pass cat. So once you do that, you'll see that the value meow has come, because of method overriding, you know which classes method has to be called. And the same is true for dog. So instead of cat you pass dog, it will print here as bark. And that is what I've explained in the examples which is out here. Okay. Now say polymorphic parameter passing. Now what do you mean by polymorphic parameter passing? So whatever I explained in the using first class and second class assignments here, that is true for method passing as well. Now what do I mean? So the thing is, like say here, public abstract string sound. There is another attribute which I pass, which is of type animal. Okay, this is because I have all the implementation and whatever whatnot here using this particular attribute animal. So if I have that, I mean I can pass a cat to it, right? Cat object. I can pass dog object, or I can pass any other attributes to it. Okay, so thing is I can do that. So if I do that, whether Java allows it or not depends again on the same thing, that whether you satisfy these conditions or not. So the ultimate condition which has to be satisfied is that the reference data type is of the type same as that of same as that of the reference data type or of the derived classes, but it cannot refer to the superclass. So again, if you see here, see the calculate salary. Now this is a method inside employee, and the attribute which I am passing is designation D1. So this is one of the parameters which is required in case of employee object. Now when you call say employee.get calculate salary and you pass designation, again this designation, if you see here, I have CEO extends designation, director extends designation. So it can be an object of type CEO, it can be an object of type directors, it can be of different types. So if you see here, how do you understand? So the way in which you understand is designation D1 is equal to designation, and see the type of object on the right hand side. If it is CEO, yes, it satisfies. If it is director, if it satisfies. But if it is not something of the type of designation, or it is a type of subclass of designation, that is not satisfied. So the basic concept is same as that of the assignment polymorphic assignment statements which we discussed first. Okay, and the same thing about polymorphic parameter passing is also true about return types. Now say if you return value here, now say in this particular example, in this test animal example, if instead of in this animal example, if instead of just returning sound, I also have a return type, and the return type is not string, say the return type is animal. So if the return type is animal, it can be of type dog, it can be of type cat, right? So that is very much possible. So if that is the case, I can return the values either cat, dog, or any other animal which is extending the animal abstract class. So that is the case. How do you know whether Java will allow that or not? So when you write something like say this, employee is equal to get employee long employee ID. So you get the value, and how do you know this is compatible? So again, whatever we learned about reference data type in polymorphic assignment statements is true here as well. Okay. Now same is true about the polymorphic generic array types. Now what that means is I can write like this: Peter, and say Peter is another class, an array of Peter, and I can assign the value of the Peter array as 4, and every value which is inside this array has to be of type Peter. Okay, and all other like role, Steve, they extend the Peter class. So that's why we can write it like this, in the same way in which we are able to write animal is equal to new cat. Similarly, we can write Peter is equal to new role. Okay, now if I come here, I pass all the values here, and in this way if you see, all the different types of objects are stored in an array. When, if you remember, array is a homogeneous type, only one type of data can be stored here. It can be either all integers, all doubles, all strings, but you cannot mix it. But that mixing is possible here. One object is Rolf object, the other object is Steve object. Why? Because they are using a common interface, a common abstract class to refer to it. So that's why, I mean, this is a sort of a tricking the entire system. So using an array which stores only the which stores only the objects of the same type, you are essentially storing the objects of the same type, which is the type Peter, but that essentially is referring to other objects. Okay. Now coming to polymorphic exception handling. So same is true here as well. Say now don't get bogged down by the try catch statements you see here. The try catch statements is from one of the exceptional handling demo classes which we had earlier. Okay, and we are going to discuss it because that class is yet to come. So if you have this try catch and you have this exception, just for now try to understand that from inside this try catch block, from inside this try block, you can throw an exception. We can throw an exception depending on the scenario. Somewhere there is a violation in the array index. The array did not have any value. You're trying to get the second value or third value. In that case, you'll get the array index out of bounds exception. So if we get this exception, this particular catch block will not only handle the array index out of bounds exception, but all the derived classes as well. So say if you write an exception class to handle, and you can write it, if you write an exception class which handles array index out of bounds, and that array index out of bounds extends, okay, it extends say first class index out of bounds, then here in the catch block you can write first class index out of bounds, because it can accept everything from array index out of bounds and from the derived classes as well. Okay, so that is the thing about polymorphic exception handling. Now if you go back and see whatever we discussed, the basic concept was same as what is written out in the first part, which is about polymorphic assignments. So the type broadening is possible in case of primitive types, but type broadening is not possible in case of Java. So if you are doing a type broadening, you have to cast it in Java. Okay, so in reference data types, and if you cast it, it will not give you compile time error, but during runtime you are going to get an error. And why you are going to get an error? You will get an error when the object which is there on the right hand side is not of the same type as that, or of the derived classes as that on the left hand side. So this is a very the very basic core concept about polymorphism as such. And I think we discussed about method overloading and overriding beforehand as well, so you must be clear about it. What I have done for today is that I have come up with all these 5 questions. One is like what is auto boxing, what is upcasting and downcasting, and this is what we have already discussed here. You just have to put a name to that particular concept, which one is allowed in Java and which one is not allowed. Is Java passed by value or passed by reference? That is the next question. Then as teachers are asking, and it's very important that you keep on writing programs. Okay, so choose small programs, whatever you see in daily world, and try to write it. So what I'll do is going forward is even for your regular practice, I'll keep giving say 5-10 programming exercises so that you can just work on it. And if you do not if you're not able to write it, you can come back to me and we can see where you went wrong. I can give one sample solution. So one program which you have to write, which accepts an input and check whether it's a palindrome or not, and then another program which prints the first 50 Fibonacci numbers. And to accept the input parameter, as I think I have already told you, you have to do a right click, do a run as, then click on say run configurations. And if we do that, one thing which you have to see is that the main class which is here is referring to the same class as whatever you want to test. If not, search for that particular class, okay, and then choose the correct class. And then if you go to arguments, here you have to pass the actual argument, and you can actually pass 2-3 arguments. So because it accepts, let me go back to the right. So if you see this particular parameter list, it accepts an array of strings. So it can accept cat, it can accept dog, it can accept rat. Only thing is that it has to be handled here. So even if you pass cat, dog, rat, we are only getting the first element from the array. Whatever is there for the second and third, we are not using. So if you say run it like this, it's not going to give you an error. Oh, it's giving me an error right now because I have changed the signature of the sound which cat and dog have implemented. If you go back to the old signature, it's not going to give you that particular error. See, all the errors have gone away. So we come here and again try to run it. You can say run configurations. I go here and see the arguments which are here, cat, dog, rat, and run it. Now it's printing me meow because I'm just using the first type. But if I want to use the second and third one, I can definitely go back and use it. So how do I check it? Say I can do like this, sys.args dot So we're using Eclipse IDE. This is a benefit. You can do args dot and then see all the things which you can access. So you will access length. Now this will print you how many things you are trying to pass. See, 3, because you have cat, dog and rat, and in here you can print it. So for printing it, let's use a for loop for string animal type. Okay, and iterate it over the args thing, and I'm using for loop. I'm using animal type because it's already defined here. So I'm using the for loop with the enhanced for loop, and I print all the animal types, whatever is out there in the argument. So do that. Let's see what happens. See, it prints everything whatever you put it as an input. Cat, rat, dog, cat, rat, dog. So this is how you can expect input for the program and then apply polymorphism over it. Okay. So my idea was to make sure that you understand polymorphism, and I think that is out there. Once you do these questions, you'll understand most of the concept about polymorphic assignment statements which we discussed here, and that is very important with respect to applying the actual concept about method overriding in the programs. Okay, so that's here we'll stop. If you have any questions, you can ask.